Hello, I welcome you all. The problem reads if the cord is subjected to a constant force of F equal to 30 pounds and the smooth 10 pounds collar starts from rest at A, determine its speed when it passes point B. Neglect the size of the pulley. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Benam. We're going to be using the principle of work and energy to find the speed when the collar itself passes, or when it is at the point B itself, or it's at the verge of passing point B. Right, so we expect to have some work done in this direction. We also expect some work done due to the weight. Right, so let's draw what we are talking about here. So this collar starts from A to, let me draw this. So it starts from A. So I'll say from A, I'll give it up to, I'll need to find the distance from A to C, and then I'll need to subtract this, right? Because the idea is we want to know how much displacement the rope will have gone down. So let's call this as S. Let's call this as S prime, and let's call this as S double prime. Okay, these are just representations. Okay, don't confuse them with derivatives, right? Or maybe let me use another sign so that we don't get confused. Let's call this S. Okay, we call this S, and let's call this S star. Okay, like so. Alright, so we are going to have a displacement along this direction. Let me just show that. The displacement along this direction, let's say from somewhere there, maybe to somewhere there, this one here. Let's say this is the displacement that we are looking at. That will give us some work. Okay, so let's call this as S star, assuming the whole lot of this length, okay, of the rope comes out. All right, and then if that happened, because this is starting from A, so we have to subtract, because this particular collar will be at B, so we have to subtract S. Is it making sense? Okay, so this is how much of this rope will have gone over the pulley if the collar is at B. This is how much length of the cord or the rope will have gone out if the collar is at B. Okay, does it make sense? Of course. And then we also need, there is also something else that we need, which is the collar we are being told will be at that. Okay, the collar will be at B, right? So it will have some, it will also perform some work due to its weight. Okay, and then let's call this also as just H. Okay, let's call this H. So we'll have work due to the collar, which is going to be negative because we have weight going down, okay, and then we have the displacement h going up, therefore negative work. Then here down we have the force going down, we also have the displacement going down, so here the work is positive work. Is that fine? Of course. So this is what we are going to experience. So this is basically what we are doing. All right. These are both S's. All right. So let's go. So kinetic energy. Kinetic energy 1 or initial kinetic energy plus the total work from point 1 to point 2 is just equal to the final kinetic energy. And this is starting from rest, and therefore this whole part is 0. Okay, and if that is the case, we won't remain with the total work and the final kinetic energy. So we have 0 plus the total work itself. So we do have F times S star minus S, okay, and this is positive. Then we have minus W, okay, times H. Then this is equal to K, which is just half M V V2 squared. Is that fine? So let's find this S star. S star is just going to be equal to the square root. So the square root, square this later on. What is, we are using Pythagoras theorem. So the horizontal we have 1, 3, this is 6. So 6 squared, and the vertical we have 4.5 squared. Alright. And then what else do we have? Of course, this is the only star. And then we do have S itself, and S is just equal to 2. Right. And we have H, which is just equal to 4.5. So rewriting this, we have 30 by square root, which I can just copy. I can copy this and bring it here, minus 2, we close, minus W, which is the weight, and this is 10 times 4.5, then equal to 1/2, then 10 divided by 32.2, then times this, and then making this subject of formula, which you can do from this equation. We have 6 squared plus 4.5 squared, square root of that, minus 2 by 30 minus 10 by 4.5 divided by that by 10 divided by 32.2 and square root of that. So we find that our velocity is 27.80. This is feet per second. Okay, that's the velocity of the collar when it reaches B. Let's work it out again. 6 squared plus 4.5 squared, square root of that, square root of that, minus 2 by 30 minus 10 by 4.5 divided by 0.5 by 10 by 32.2 and square root of that. Alright, so we are done, and we've calculated the velocity of we've calculated velocity of a collar when t is at the verge of passing point B. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.